So just to recall what we did in the last session. In the last session, we mainly talked about the higher order function. We talked about map higher order function. Just a second. We talked about map higher order function. I said that map takes a function whose type is same type as the collection type, and it could return some other type. Finally, it will return a collection of some other type. So the main use case of the map higher order function is to transform the data. You have a data, you have a lot of records. You have a data set and there are a lot of records, and if you want to transform each element to something else, we saw that we could use map higher order function. Similarly, there is filter higher order function. Filter higher order function is to filter some records from your data set. It's just like using some where clause in the select statement. Select some things where salary is greater than some standards, where age is greater than 24, something like that. So the same thing we can achieve with the filter higher order function. Then again we saw one more higher order function, for each higher order function. For each is almost similar to, in syntax wise, it is similar to for each map higher order function, but only thing is it returns unit. It takes each element, it returns unit, which gives a totally different meaning to the for each higher order function. Whenever we return a unit, return data type is unit, means it has to modify something. So we use a for each higher order function to save the elements of the collection. Saving is something called as modifying. We can save it to a file, we can save it to a database, we can save it to some message queue or some global data structure, anything. So that's what we saw about the for each hierarchy. The last that we saw was the reduce higher order function. So reduce higher order function, it takes two parameters, and here it will be the body of that function. That function, the reduce higher order function, is a higher order function which takes a function. That function takes two parameters, and those two parameters are somehow used in the body of the function. So, and I said that the first parameter is called the accumulator, the second parameter is called the iterator, and the name itself says that reduce reduces, that it works on the whole collection and tries to give a single element. So the name itself says that. So the way it loops through all the elements is through the second parameter, which is called iterator, and whatever operation is done in the body, any operation that is done in the body is stored back in the accumulator. And finally, that accumulator is being returned. Hence, we get a single result from a collection using the reduce higher order function. So that's what we talked about, the map, filter, for each, and reduce higher order function. And there are many other functions as well. We can see that. If I say val colors was one of our collection, I need to define individual users. U1. So there are 4 users and or employees, anything we can say, and val users is equal to, we had defined a collection of such types. And we know that we on colors, if you press dot and then press tab, you will get all the methods available on that collection. So there are a lot of methods available on collection. Some are higher order functions, some are not higher order functions. We usually saw a map higher order function. We saw this map higher order function. We saw reduce. There is something called as reduce left option, reduce option. We will see. I mean, slightly there are some differences, but we'll see that later. As soon as we encounter any problem, we will see that. In a similar fashion, there is a fold higher order function. If you see here, there is a fold higher order. The basic difference between reduce higher order function and the fold higher order function. The functionality remains the same. The functionality remains the same. Fold and reduce. Both will work on a collection and they will return a single element. You can see that fold also is, the name itself specifies, fold every element and give you a single element. Reduce also takes all the elements and reduce it to a single element. Both functionalities are same, but there is a slight difference. The only difference is that here, when I say val nums is equal to a list of 4, 5, 6, and 7, and on nums I call reduce function, which takes two parameters, which takes a function that takes two parameters, and let's say it returns x plus y, the body. So we know that x is always initialized, as I said, x or we call it as an accumulator. Accumulator is initialized to the first element of the collection, always, by default. I mean to say, not by default, it's always. So, so fold, that's where the difference comes with reduce and fold. Fold gives us the flexibility to explicitly initialize the accumulator. On nums we have the fold higher order function. Along with being a higher order function, it is a currying function. We know what is a currying function, multiple parameter groups. I have one parameter group and I have one more parameter group. The second parameter group is same as reduce. It takes a function which takes x and y and gives some. Now what is the first parameter group? Here in the first parameter group, I can explicitly assign a value to the accumulator. So in case of that's how the fold higher order function works. That's the difference between reduce and fold, we can say. So in this case it will be x is equal to 4, y will be iterating from 5, and the result will be stored back in the accumulator, that is x. Again y will iterate to 6, so both will be added and the result will be stored in the accumulator, and again y will be 7, both will be added and it will be 22. So this is part of the reduce. This is our reduce. But what happens in case of fold? So it will be, x will be initialized to 10. X is no more, or the accumulator is no more initialized to the first element of the collection. Accumulator is explicitly, it gives us the flexibility so that we can initialize it to some our own value, and y will be starting from 4, but totally everything will work the same way. Finally x will be 32. So that's the difference between reduce and fold. No, that's not possible with the reduce hierarchy function. Here is a question. The question is whether we can override the accumulator so that it points to 3, not 4. No, it's not. That's the syntax of the uh, reduce hierarchy function. It will always point to the first element. That's where it has to go to. That's the use of reduce. It goes through all the elements of the collection and returns a single element. That is a specific use case of something like sum. We want product, we want min, we want max. Such kind of the use case is solved through the reduce hierarchy function. I hope that was clear. Here is one more question. The question is where and when we use the fold higher order function. What is the use case of fold higher order function? I have one use case. I mean, I don't know the generic use case. There is one use case that I have used fold for. I will discuss that in the Spark. I will showcase that fold example. That I will show. I mean, there are many things here. Right, right. That's the difference between the reduce and the fold. I mean, in reduce you don't get to initialize anything. Here it becomes here we get the flexibility of initializing the accumulator. It's more generic than the reduce, we can say. It is more flexible than the reduce. There are some other functions also. We have seen the take function. We have also seen tail function. We have also a split. We will see there are it will split the collection at a particular index. Such kind of the functions are. So here are some other functions. These are also a function. Plus plus is a function or method we can say. This is called a cons method. So these are all the methods that are available on the collection. We also saw the drop method, which drops an element from the collection. So, like we have this function, cons is one more function or a method. Cons is one more method. The main responsibility or the functionality of this method is to add an element to the head of the collection, to the start of the collection. That's all. So we can use something like this. I can say colors2 is equal to colors dot. I will call that method. Dot is always used to call the reference the members or the methods of a class. We know that colon colon is a method, and we can pass something called as, so it adds an element to the head of the collection. So we can see that purple has been added. That's the functionality of colon con. It is called as a cons method. Now there is slight thing we need to know about the cons method, or the method that ends with the colon. No, no. The question here is colon colon also used to add an element to the end of the collection? There is separate method to add an element to the end of the collection. We can check that. We can check that. But there is a slight thing we need to understand about the colon method. So what we said is we had nums, val nums equal to list of 4, 5, 6, and 7. Now any object, any method that you want to call, we call in this fashion. Nums dot map is one function method. Nums dot filter is a method on that. So we use the dot reference always. Nums dot reduce something, or we just have val x is equal to 10, and we have val y is equal to 20, and we just say val z is equal to, usually say x plus y, which internally means on x we are calling plus method and we are passing y as a parameter. I mean, this plus method is being called on the object on its left hand side. Sorry, not on this. This plus method is called or associated with the object on its right hand side, the plus method. So there is a slight difference in the cons method. This is called as cons method. So any method that ends with colon, is associated with object on its right hand side. So here we can clearly see that plus is associated with object on the left hand side, this one. So but whenever the cons method is used, or the method that ends with the colon, any method that ends with the colon is associated with the object on its right hand side. So you cannot say nums colon colon 10. This will not work, because since this method ends with colon, so the compiler will try to associate it with the 10. It will try to say 10 on 10 object, call the colon cons method, and pass nums as the parameter. That's how the compiler will treat. So it will give an error because there is no such cons method on integer. The cons method is only available on a collection, list collection. Obviously it will give an error. So it has to be on the reverse way. The same thing if I want to do, I just say the element first, then I will say colon colon then I will say colors. So the object, so on colors, now this method is being called. So that's what we just need to remember. It's just a reverse way, that's all. It's a reverse way how the evaluation happens from the right hand side, not on the, as for any other example, it will be always on the left hand side. The const method is associated with the object on the right hand side. So that's how we usually use the const method. But the functionality is simple. Functionality is just add an element to the head of the collection, that's all. Similarly, if you want to add an element to the tail of the collection or end of the collection, there is a method called colon plus. So I can say val colors3 is equal to colors dot. There is a method called, this is a method. This is a method name, and I can say blue something. It will add an element to the end of the collection. To this, to this, after pink we should get a blue. So these are all some methods we can use to add an element to the head of the collection or the tail of the collection. But since it does not end with colon, as you can see, this method does not end with the colon, hence it will behave regularly. It will behave regularly, it will be associated with the object on the left hand side. We just have to say, instead of using the other syntax also we can use, I can just say in this fashion. If you see, it was reverse here, this is the regular fashion. It means that on colors we are calling this method and we are passing this as a parameter. This is also, so just need to remember that. And there are many other functions, you can try all those functions. Even, I mean, I haven't tried all the functions. Probably if you have anything question on a certain function, you can talk to. You can ask me on that. Now just like we have a list. Just like we have a list, and I said that list is not good for random access. Yeah, here is a question. The question is there any reference docs to refer all these functions? I mean, the only way we can do is we can just Google for these stuffs. The other way, I'm not sure how. I mean, there is nowhere it has given all the function references. We have to just Google for these functions.
Pramod, don't we have any API kind of thing where, like a UI, where we can see these functions, their hierarchy wise?
I mean, the Scala doc should have. So I can say Scala zip with index. So you can, this gives the scalalang.org gives all the APIs. So you can search things here, I think. So we can go and search here. So this gives all the APIs, their syntax. So this is what you are looking for, right? Here we get everything, but it may usually don't have concrete examples sometimes. But Scala or langs.org has all the API details, references. Zip with index, so it gives the details on that. Some function example is also there. Or we just Google it on the, so you get multiple references. There are a lot of examples on that zip with index. But scalalang.org is the official one on the Scala, where you have the all the API references. So what we were talking about is, as I said, a list is not good for random access. If you see, most of the time when we did a map transformation, we went through every element. It was not a random access. Sequentially, we traversed one after the other. So whenever we want to sequentially traverse one after the other, so that's where the a list is good. It is good for sequential traversal of every element. List is mostly used for that purpose. Like we did a map transformation. The map transformation, first the first element was there, next the next, third, fourth, and the last. That's how the map transformation works. That's kind of a functionality if you want to use. So we can use a list hierarchy. Sorry, list collection. In a similar fashion, there is something called as a vector. I am just trying to give the difference between linear collection and indexed collection. There are two types of collection. We already saw the linear collection where the implementation is such that we have to traverse in a linear fashion similar to a linked list. Now what is the indexed collection? Our array is an indexed collection. Array is the indexed collection means whenever the difference between array and list is something like this. List is, we have element 4, so it will be pointing to one more location somewhere else, again some other memory location, some other memory location. But the array, whenever I say array, all the elements are stored together in a contiguous memory. This is a continuous memory location. So when we have contiguous memory location, accessing is an element is of constant time. You just need to know the base address. You just need to know the base address. Base address plus the offset will give the first offset will give the first element. Base address plus the second index will give the second element. Base address plus the third index will give the third element. So the accessing of data is constant. It does not take a lot of time to access the element of a index. That's what we call it as an indexed collection. We don't traverse it. It is contiguous memory location. to the base address, we just add the index, we get the data. That's the difference between the array and the list. Arrays are all good for random access. I mean, array is good for random access because it, irrespective of how the data is stored, you always end up accessing the data in constant time. So that's where we call it as a random. In a similar fashion, vector is also a indexed sequence. Vector is also an indexed sequence, but the way they have implemented is slightly different. So they have a, I don't know why they have used, they have 32 memory locations, contiguous memory. They allocate a contiguous memory for 32 elements. And here we'll have the zeroth element, first element, second element, and so on. All the 32 elements are stored here. Now if you keep on adding new elements, because we can add any new elements to the vector. So what they do is, as soon as they are filled with 32 elements, what they will do is they will create one more memory location which can hold 32 elements. They will hold one more, they will create they means the compiler. Internally, these all things happen internally. The only API that exposed are, we will see that. Just like list collection, there are some methods exposed. Similarly, we have some methods exposed for the vector collection also. But I'm just trying to give how the internal implementation is. Internally, the way it has implemented is, as soon as you try to add more elements, it creates one more contiguous memory location of 32 element size. In a similar fashion, as that also increases, and instead of storing the data here, it will store a pointer to this. Right. This is how it maintains the address of the each array, we can say. And again, as the data keeps on getting added, it will instead of keeping the data here, it will reference the pointer. The same thing keeps on happening. This will be pointing here, this will be pointing here, so this will be. So it is right. It is like a tree structure. That's how the internally a vector is implemented. Now, as and as keeps on increasing, it goes for the next level. It goes for the next level. And at that time, this element here, element will not be stored. Instead of that, it will be replacing the address. So again, this will have a link to 32 memory, 32 contiguous memory locations. Now we can see that. Let's say I want to access 100th element. Now let's say data does not exist here in the first 32 contiguous memory location. Let's assume that everything is a pointer. Everything is a reference to another memory location. So obviously here we have 32 elements, here we have 32 elements, here we have 32 elements. That comes around 96, 97, 98, 99, 100th element is here. Now how much time it would take to traverse access the 100th element? So obviously first it has to access this address. This address it has to access. We know that this is a contiguous memory location. Accessing this address, this location is of constant time. You take the base address plus the index, it will give the this value. Here actual address will be stored, so it will traverse to this base address, and accessing any element in this location is again constant time. So it has to traverse only once. One traversal was required. So if you take any element here also, if you want to access some element here, let's say 40th element, somewhere the 40th element will be there. Obviously there again it will take one traversal. If I want to access 90th element, obviously the 90th element will somewhere be here. Again it will take only one traversal. So what I'm trying to say here is, if it wants to access any element on the second level, this I will call it as first level, this I will call it as second level, and so on, multiple levels. Any element it wants to access on the second level, it's only one traversal. So you randomly choose any element, the number of traversal is very less. Any element it wants to access on the third level, number of traversal will be 2. That's all. So that's how a vector is implemented. I mean, it is just for understanding purpose to give the difference between linear collection and a indexed collection. So whenever you are randomly accessing, because it is good, now we know that why it is good for random access. So whenever you want to search for a particular element, I mean randomly you get the index and you get the value for at that index. Randomly you get the index and you get the value. Such kind of a use case you have, so it is always good to represent your data as a vector. That's the use case of vector. Even though the implementation in this fashion, the way you create a vector is simple. We just say val v is equal to, that's all. Just instead of using list keyword, we use the vector keyword. And we can just see all the methods that are available on the vector. Most of the most of the methods remains the same. We have init, we have min, we have max, map, higher order functions. We have most of the methods remains the same. That's how we use the. I mean, only thing we need to know is the difference here between the normal linear collection. I mean, difference between the linear collection and the indexed collection. Similarly, I mean, if you want to access the element, the same here. Each element v of 0 will give you the first element, v of 1 will give you the second element. And as I said that internally it is nothing but the apply method is being called here. So in case of list or a vector, the apply method is used to access an element of a collection. So that's the vector here. That's what we know about vector. In a similar fashion, there is one more collection, as I said, a set collection. Now set collection is a collection of unique data types. Unique data. Set is a collection of unique elements. That's what a set is. Even though you have duplicates, every duplicates will be removed from a set. So we can say val, and the syntax is just like this. I can just say 1, 1, 2, 3, 4, 2, 4, 3. So we can see that 1 is repeated, 2 is also repeated, 3 is also repeated, and 4 is also repeated. But those duplicates will be removed from the. That's how the set looks like. I hope my audio is, I'm audible. There is some, it shows some problem. That's fine. So the use case of set,
Promote.
yes.
Uh, so since it is arranging it randomly, so how will we know at which position the particular element is there, and how can we access that one?
Right. That is not the use case of a set. The use case of set is not that. The use case of set is, as it is to check for the membership. Since it's a unique collection, the use case is to check for the membership, whether phi exists, whether one is a member of this collection, whether two is a member of this collection. So in that case, so what could be the result here? If I say s of 0, so it is not, as I said, the use case of the set is to check for the membership. It is not the index that we are accessing. We are not accessing the elements. It will check whether 0 exists in the set or not. Since 0 does not exist, it returns false. It checks whether 4 exists in the set or not. So it is, say such is a true. So that's the use case of a set collection, just to check for membership. Just to check for membership. So I hope that was clear.
Yeah, thank you.
And there are again certain methods that are available on the set. Some methods we can always use. We have again max, min, a head element. I think head should give, any collection head should give the first element. Any collection head we have, uh, tail we have. Tail will always give the, instead of head, it will give all the elements. Any collection set dot init will give the last element. These are not the use cases, but we may sometimes want to access. Last dot init will give, except the last element, it will give the rest of the elements. But may not be we use it as a use case. If you want to explicitly assign some index to those, if I want to explicitly assign some index to that, so that's where the zip with index comes into picture. It is a common method for all the collection, zip with index. So if I say set dot zip with index, it will just return a, it will assign some index to that, starting from 0. I think the second element was this, third element was this, fourth element is this, last element is. I need to, probably the internal data structures may be slightly different. I'm not sure what is the internal data structure. For every element, it will give a index, 0 index, 1 index. I mean, On set it doesn't look much good. Let me show it on the colors. We have colors dot zip with index. So it will assign a index 0, 1, 2, 3 here. So that's what the zip with index will. Just gives some elements to each element, assigns some values to each element starting from 0. So that's what we have set here. I have examples of set. I will share that code. It's usually, I mean, collection of unique elements. It has been, I have used it in some machine learning uh, labeling point there. That's what I have used it for. It could be some other use case also where you want unique collection of the data and check whether a element exists or not. So I can share that code once we go through the Spark. Yeah, here is a question. The question is whether these indexes are the memory IDs for the elements stored in the memory. No, these are not the indexes. It is just mapping a number to these elements. That's all. Again, these are elements only. Now we get a one more collection in this fashion. We get one more collection as a tuple. You can see that it is a collection of tuple. It is not an index. I mean, normally the way the index works as a index in case of an array, it's not that. We are just associating a number to this. I hope no, it will not be randomly. It will start from 0. We know that first element is green. For the first element, it starts 0. Second element, 1. Third element, 2. And fourth element, 3. It's not randomly, but starts from 0 and monotonically increases. Now, like we have sets, we also have something called as map. Map is one more collection. We know about hash map. Map is nothing but data will be stored as a key value pair. So like we can have this is the syntax to create a map. This is a map collection. Map collection is the data is or the elements is a key value pair. These are all called as key. Keys and this is all value. So that's a map collection. In Java it is called as hash map. In Scala we call it as a map. So these are all the different collections that are available. You look for, you want what is the value for S. You just do a lookup. Probably like you may have uh, 1.6. Usually you have IP address 1.6.20.43, something like this. 1.5.250.192, something, some IP address. We have some IP address in this fashion. Or we have some If you see, there are some pin codes 560097. Some pin codes are there. So this pin code could be mapped to some 56 may be mapped to some district or some state. I'm not sure. 5 will be usually the pin codes are something like 5 will be mapped to north region or south of India. So there is some kind of a mapping. So that's where we use it, hash maps. Like 1.6, 1.6 may be Japan country. The IP address 1.6 belongs to Japan. The IP address 1.5 may belong to India. So you can have a map collection of this 1.6 as Japan. So you just want to do a lookup. Whenever you have a IP address, you do a lookup and you figure out that that IP address belongs to Japan. And we have 1.5 belonging to. So you have a collection of such types. We have a collection of such types. So that's where we store the data in a key value pair. It is used for lookup purpose. You give some key and it returns the value associated with that. That's the use case of a map collection. Just you can see that the difference, there is just one capital M. Capital M means collection, small m is a higher order function. We need to just know that difference. Capital M is a collection, small m is a higher order. So I can define a collection something like this. Usually it is used for lookup purpose. I will just name the identifier also as a lookup. Just say map. This is the syntax. You need to remember this syntax, arrow mark. If you remember this arrow mark symbol, we had also used some time before. I will just recall that. This is first element. J is the key, I will say. Java is the value. R is the key and Ruby is the value. So if I want to access lookup and I will say S, it will return. I'm passing S to this function. It returns Scala as the return type. I mean, if you remember, colors, we use colors was a list. Colors of 0 used to give the first element. Now we don't have anything like that. We don't have anything like that. We have to pass a value, sorry, key, and it returns a value of that corresponding key if the key exists. So you can see that both are apply method. I initially said that internally it is actually calling the apply method. So you can see the implementation of apply method is totally different. In a list, the apply method is used to access the elements. In vector also, apply method is used to access an element. In a map collection, the apply method is used to return a value for a corresponding key. Similarly, we have seen the set. Set of 0, what it says, it checks whether 0 exists or not. So in set also the apply method is different. Similar to apply method is different. We can imagine, yes, we can compare it. It is slightly similar to get method, we can say. We could say that. But they have defined a simple apply method. Now there are Now we have also seen this syntax. If you remember, I told this syntax we have already seen. So I said that this syntax is used to create a two-element tuple. When I define in this fashion, it creates a two-element tuple. I said it. T dot. So T will be the first element. S will be the first element of the tuple. Scala is the second element of the tuple, and the way we access is T dot underscore one, T dot underscore two. So what I'm trying to say here is map is nothing but a collection of tuples we can just imagine. Map is kind of a collection of tuples. So we can just say there are again lot of methods available on this lookup dot. There are many methods available here. We have a minus method, we have a plus method also available. These are also the methods. There is, I think it's a, this is a fold method. This is a fold method, I suppose. Like we saw the fold on a list collection. This is also kind of a fold. I haven't used this, but in list I have used. A lookup is an identifier. Here is a question. The question is whether a lookup is is an identifier or a keyword. It's just an identifier. I can just say anything. I can just say something ABC. It's just an identifier. I mean, I wrote a lookup because the use case of a map collection is for a lookup purpose. It's mainly used for lookup purpose. You specify some key and it gives a value. So I just say ABC of J, it will give you the Java. ABCR, it will give Ruby as the value. That's how the data is stored. And I said that internally we can the way the data will be stored is kind of a tuple. Each element is a tuple. So there are methods like you get the keys. We only get the keys here. I want only values. There is a method called values. I just call that method values. It will only give you the values of that collection. Values of this. So these are all the, and we can also apply map higher order function here. We know that map higher order function takes each element of the collection. The same things, the same things we can get through the map higher order function also. So we know that what is a map higher order function. We have a val ABC is equal to a map collection where S I have Scala, J I have Java, and I have R value is Ruby. Now I can on ABC I can call the map higher order function. I can pass some function. We know that this function is called for every element. This function is called for every element will be passed as a parameter. First to this function, this will be passed. The next time, again Java, this will be passed. Next time again Ruby will be passed. This is how the looping will happen. We know that map higher order function takes each element of the collection map higher order function takes a function, and that function is applied on every element of the collection. So if I want to get the key, how can I get the key? Using get keys using map higher order function. How can we get this? Get values using map higher order function. The, we all when I say keys, we should get S, J, and R. When I say values, I should get Scala, Java, and Ruby. How can I get that? No, using map higher order function. You need to use map higher order function and get the keys. This is one program. This is one more program. So we know that map higher order function takes a function. So I can do lookup dot map. I will not define a function. I will directly use the shortcut. Or first I can write the function literal. Function literal means it needs to take a parameter. The map higher order function takes a function. That function takes a parameter, which is each element of a collection. S is each element of the collection. What is S here now? S, we can treat it as a two element tuple, which is each element. Now if I want the first element of the tuple is nothing but the key here. So I can just say _1 will give you only the keys. S, J, and R. So if I want only the values, I have to just say this. So we have to just say this. Here is a question. The question is, what is S here? As I said, S is each element of the collection. That's how you have to remember. So if I go in detail, right? So usually you have to define a function. Just say get key. I will just define a function get key. It has to take, yes, S is just a variable to access each element. Just to dissect the whole thing, how I arrived at that shortcut, you have to define a function. What is the map higher order function? I'm just recalling because there might be some confusion here. So if I have a collection of type A, on this we pass a, if I call a map higher order function, map higher order function takes a takes a function same type as the collection type and returns some other type and finally gives a collection of some other type. So now we are having ABC. Now A is nothing but what? A is nothing but, what is the type here? Type is kind of a tuple, string, comma string. Key is also string, value is also string. So we need to pass a function that takes a tuple as the input parameter, same as the collection type. and it should return something else. So we can say, we can just give anything here. If I say S here, it should take a string and it should return a string. Sorry, it should take a tuple, and here I'm returning p dot underscore 1. So as you can see here, this function takes a tuple and it returns the first element of the tuple, which is again a string. So obviously we can pass this to a map higher order function. We can pass it to get key because get key matches the function data type.
This I understood, Pramod, get key, but can you type only the yes? No, now,
Now if you see,
what is yes?
I wrote the same thing. I wrote this same thing. I just wrote the same thing. Instead of this, I said yes dot underscore 1. What happened? Okay. Not found value S. Why this? Oh. So I just wrote the same thing. This function literal. I wrote the same function literal here. The only thing is we need not specify the data type altogether. If you see, the very first time that I wrote is, that's the function literal that I wrote.
So it's implicit that yes is a tuple and we are getting the first element. It is returning the first element,
Right.
right?
So the implicit, what you can think is, whatever identifier you give here, that identifier is an element of this collection. Since this collection is a key value pair collection, yes is a key value pair element. So yes will
Yeah.
always be, I mean, any identifier you take. I can just say, if I take colors now, colors dot map, I take yes, any identifier. That identifier always says each element of the collection. In this case, it will be a string. I can just say string dot size here. So I can just say anything, a b a dot. You can specify any identifier. It will always
Yeah.
be as the element of a collection. And you need to know what is your collection type. Based on your collection type, different methods will be available on that identifier. So that's the best way to remember what is the parameter. The best way to remember is just you can keep in mind that it is each element of the collection. Each element of the collection. So that's how we can, using the map higher order function, that's how we can get the keys and values. We had this lookup dot map. It takes each element. Now we know that this element is nothing but a tuple because internally it will be a two element tuple. To access the first element, we can use underscore 1. To access the second element, I can just say now just like we have map higher order function, the filter, all those higher order functions are available. But there is one more new function on the map collection. So that function is called as mapValue function. That is one more function. Like we have map higher order function, there is a mapValue higher order function. Now what is the difference between these two? We know what the map higher order function does. It takes each element and it transforms to some other element based on what the logic we give. It transforms each element. Now what if you go on the similar lines, what will mapValues will do? What the mapValues will do? Now here I can write the definition. Maps each element. Maps or transforms. I can just say maps. The best word to describe that is maps or transforms. Transforms is the best word. Transforms each element to something else based on the logic. Similarly, I think somebody transforms only the values. Right. That's what the mapValues will do. It will only transforms the value. Maps or transforms only value part, because our collection is in a key value form. This is treated as key and this is treated as value. mapValue function maps or transforms only value to something else. It keeps the key as it is. So what I mean by that is, whenever I say map, it takes, whenever I say yes or any identifier I specify, I always said that it represents an element of the collection, each element of the collection, and I can do some transformation on that. When it is on lookup, I can just say element. This is each element. E is representing this. This is our E. Next it will go to this. Next it will go to this. In a similar fashion, whenever I say lookup dot map value, now E will be only this. If any identifier I can give, ABC, anything. Now that will be only the value. The input to this map higher order function is only the value part. I will say A here. It takes each element A. So this is A. This is A. It takes only value as the input parameter, so we can do something on that. The key part is kept as it is. That's also we need. Only the value part transforms only value, and key is kept as it is. That's what the mapValue higher order function is all about. So let's say now whatever element it takes, it is also a higher order function. Just like map higher order function, this is also a higher order function. It only transforms the values. Now E is only value. E is not each element. It is only the value of each element. So since E is only like Scala, Java or Ruby. Let's say I want to get the size of each string. So I can say E dot size. The key will be kept as it is. Key will be kept as it is. Only the value is transformed from Scala to it will be transformed to the size of that Scala, that is 5. Java will be transformed to 4. Ruby will be transformed to again 4. But the key will be kept as it is. We are only transforming the value. So I hope you got the difference between map higher order function and the map value higher order function. If we want to transform only the values, we can use it in this fashion. I mean, we can achieve the same thing. We can achieve the same thing with map also. We can achieve the same thing with the map also. But now, as I said, E represents each element of the collection. Now, what is each element of the collection? Each element of the collection is nothing but key value. Where is it? E is nothing but this. It is not only value. When we take map higher order function, each element is a so E is a tuple. E is a tuple. So we have to keep the key as it is. Key as it is. Value we have to change it. E is a tuple. E dot 1 will remain as it is. E dot underscore 2 is the E dot underscore 2 is the value dot size. I mean, we are keeping the key as it is, and we are changing the history. So you can see the difference here. You can see we can achieve the same thing with map also. It's more extra piece of code we have to write, but with the map values, we have to just say that. Because map values internally take care of keeping the key as it is. But here we have to make sure we have to return, because it takes each element. So we have to return the key as it is. Value should be changed. Similarly, we can have a lookup. Similarly, we can have a I can just say employee lookup. I can just say a map collection where the key will be employee ID, value will be user 1. Value will be user 2. Value will be user. User. So we have a map collection. We have a map collection. If you see here, the first, which is a key value pair. Key, it is a integer. All are integers. Value, we can see it is a tuple, which is a employee record, which is an employee record. So you just give the input as give me the employee details of employee ID 1000. So we have to just say So you give the input as the employee ID, it returns the employee record. So ID, it gives the employee. Now we can only, you specify you want only the employee name and employee city. All those things you can try out. How do I get only the employee name and employee city? From the map collection using the mapValues higher order function or map higher order function. Just try those stuffs. And if you get any problem, just let me know on that. Now if I say here is a question, the question is there any way to find the list of employee IDs? Before applying employee lookup. Oh, okay. List, or you want to check whether this employee ID exists or not. Do you want to know the list of employees IDs or whether this employee ID exists or not? No, list you can just say dot keys. Dot keys will give only employees because keys are the employee ID. If at all you have stored the data as a map collection, keys will only give the employee ID. So now if I say employee ID of, I want all the employees whose employee ID is 1000. Obviously there does not exist any employee ID. That's where it will throw an error. No such element exception you will get, a runtime exception you will get. This is a runtime exception that you will get, no such element. Now how can I handle such runtime exception? So to understand that, we have to learn one more thing. So I hope this map, the collections, these are the collections I wanted to talk about. These are the basics of the collections. I mean, a lot of things we have learned, not just the basics on how to apply higher order functions on the collections. So there is something called as few more collections. That collections are called as, these are a separate topic. These are called as monadic collection. So in monadic collection, there are three types of monadic collection. One is option monadic collection, either monadic collection. One more is tri-monadic collection. So these two we'll see later. These two we'll see with the Spark example. But this we'll try to see it now. So option, what it stores is, it is a collection as I said. So there only two things are defined. You can only store two elements. So that element name itself is sum. It is some object. It is called as a sum object. One more is none object. In either we can store two objects. That object are named as right object or left object. Similarly in try we can store two objects. So those objects called as success object and it is called as a failure object. So we'll see these two. I will explain the option one. The other two will see that later. So even though two objects it can store, but only one could be stored at a time or one could be returned at a time. Even though two objects are defined for this collection, that's the better way to say. Two objects are defined for this collection, but it can only hold one object at a time. Either it can hold some object or it can hold none object. It cannot hold both the objects at one time. So these things are used for error handling. So as I said, either it can hold either of the one object. Either if I take options, it will hold some object or none object. If I take either collection, it will hold a right object or left object. If you take try collection, it will hold success object or failure object, not both. So we can just have a check. If it contains a right object, do some processing. Else, else if left object, I can say some error. So for such kind of, uh, we can use these monadic collections for error handling. We can say if some object, if you are using option monadic collection, we can say process this. Else if none, else if none, it is the error something. So this way we can handle the errors using these monadic collections. So let's see an example here on the option monadic collection. So I can define a function which something like this. Get element which takes my lookup collection, which takes a data type as a lookup. It takes a map. I will just say L. It takes a map collection of type string, comma string. So I can pass any collection, map collection to this get element whose data type is key should be string and value should be string. So obviously I can use the lookup. So and I will say it returns options of string. So I can say it returns options of string. So how can I do this? So if I can say L dot so I have to write a try catch exception. Let me check. Let's not do this. Let's not do this. I have to write a bigger code here to showcase that. So I didn't want to give this because it's slightly different. So we got this exception, right? We got this exception. If the element did not existed, we got this exception. If we get that exception, we can just say no. So as you can see here, I have written a function. I have written a function get element. I have put it in a try catch. I have put it in a try catch. So I pass the key. I pass the key and I do a lookup on that key. If the key exists, it will return the value. Now I'm wrapping that value in the sum object because I want to uh, demonstrate how to write a option monadic collection. So it returns the sum object where it wraps the actual value inside it. The actual value is wrapped inside sum object. But if I pass some key that does not exist, if I pass some key that does not exist, I know that I will get a no such element exception. So I catch that exception and I just return none object. I just return none object. So I can use this get element. I can use this get element and pass the key here 1000. Oh, sorry. Uh, Key is nothing but, or I can use it on the colors, not colors. What is lookup takes a string, right? My mistake. I should have made it as
Is sum a class? Sum and none is a class?
internally it is. Internally, some and none is an object of some class.
Okay.
Employee lookup. My mistake. I'm sorry for this. Get element. I need to use my try. Employee lookup, and I just return sum of value. So, but if I get a exception, I need to catch that exception. So let's say if the exception is catch that exception, we catch it with multiple cases. Case E is of the type is of the type oh, key is int, right? Again, sorry, I am making a lot of mistakes here. What I will do is I'll just write it here. Key is an int. Thanks for that. Employee lookup. So this should be fine. Shy is fine. Enough value. Then I have catch. So this should work. This should work fine. As you can see, this function takes the key is an int. It now says the return type is option. It says the return type is option of value. Value is nothing but this is uh, a tuple, user's tuple, right? Employee tuples, which is employee ID, employee name, employee age, employee city. So it is an option of that value. So either it will return none object now, or it will return some object. If the record exists for a particular key, we are returning some object. If the record does not exist, we know that we'll get an exception. We are handling that exception, and we are getting none. So we can just use this get element. We can use this get element. I can just pass 1000. You can see that the actual value we got that was wrapped inside the sum. If I say 1001, it works fine. If I say 1002, I get this record. If I say 1003, also fine. If I say 4, this time I did not get
But
the runtime error. I did not get the runtime
but
exception. I'm
but
just
change the type from user to sum, right?
sorry.
But it changed the type to user to sum.
If we change the type user to sum,
No, no. It changes the type of user that collection
correct.
collection user to sum.
Sum. So sum on that object, sum is the object, right? I can just say val uh, uh, record. I will say
We are getting the result, but we are losing the information. What type of collection it is?
no. This it is showcasing. So I can just get the whatever is wrapped inside the sum object. I can get it using there is a method on that. So it gets the we can get whatever is wrapped inside a sum object. We can always use the get method on sum object. So what could I have done is I could have done this get element is my defined function. It returns a sum object. On that I can do a on the sum object there is a method already available get which actually returns the value. So if I say anything else here 2000 sorry get we cannot use because no such exception. So this time we are not getting a runtime exception. We are just returning none object. So that's how we can achieve the error handling in this fashion. This is whatever I have defined here now. Get element as a function. This is my defined function. This is my defined function. There already exists such a function in the map collection. We can just see. I can just say on employee lookup. There already exists. I always used this, right? 1004. If I say 1004, I will get a runtime exception if I use the lookup apply method. But there already exists a method. Whatever I defined, the get method. They have defined a get method just like I have defined in this fashion. Just like I have defined in this fashion. I just wanted to showcase how options could be used, and they have already defined such options here. So which returns if nothing. We also got the same thing, right, with my defined function. They also defined the same thing, and if I say 1, it returns the same. It's already available there. It's already available there. So that's how we can specify. So we also have a lookup. So lookup is there. Lookup of R will give fine. If I say lookup of P, I will get a exception. Lookup of P if I give, I will get a no such element exception. So instead of that, I can just say lookup dot there already a method exists which returns. So there also exists, instead of using in this fashion, there also exists get or else is also there. Get or else. Get the value if it exists. Get the value if it exists. Else we can specify some default value. If the exist, if it exists, get the value for that. Yes exists, hence it gets the language Scala. J exists, hence it returns Java. P does not exist, we can just say unknown. I mean, it might have been implemented in this fashion. So it's the same thing. It might have been implemented in the same fashion. It takes a string as the key. Instead of employee lookup, I will use a normal lookup, which is this. If the key exists, get this. If it does not exist, case none, it may be. So they might have implemented in this fashion. I mean, we can default value something. So they might have implemented in this fashion get or. They might have implemented in this fashion. If the key exists, just return that value sum dot get. If you get no such exception, whatever we have passed, just return whatever we have passed. We can write our own. You can check this also. So I can call get or else method, and I can pass the key as this. Not in, sorry, key as this, and unknown language. It will return Scala. If I pass P, it should return unknown. Whatever we have passed. So that function, what we can write, they have already implemented such things. They have already implemented such things on the collection itself. So that's how they are using this option monadic collection is used for such error handling, such case of error handling. So I hope I hope this option monadic collection was clear. Probably I will.
Pramod?
Yes.
Yeah, this get or else is in an inbuilt function, I mean, or else inbuilt method that we have in Scala.
Yes. On the Scala.
So then in that case, you just called get or else of S. S is a key which is already defined. in one of the collection. What if there are multiple collections where we have keys S multiple times in a different collections? Which one will be retrieved there
No, no,
when we just call as literals of S?
no. This we are talking about the map collection, and map collection will have only one key value pair. It cannot have duplicates. For a key, there will be only one value. I mean to say there will be no duplicate key value pair. So if I say, yes, something like this. So it will only have one. So that's the property of the map collection. And only map collection is used for lookup purpose. You cannot have two keys, two similar keys. There will be only one key. Otherwise, the lookup purpose will be gone. The purpose of the lookup is gone. So I hope that was the question.
No, Pramod. If I have a one more collection lookup 2, which is also a map collection, in that also I have a key value pair where the key is S.
Okay, you are saying,
So then in that case, if I call as get or else of S,
so you are saying there is one more, say lookup 2. Yes, I have I J I am having as 4, root R I am having as 4 something. So you are saying in this fashion.
yeah. So if I use the method like get or else,
So you need to our own defined method you are saying, right?
no, you mentioned get or else is an inbuilt method, no?
Inbuilt method on the collection. So this collection has its own get or else. Lookup itself has its get or else. I can just say takes it can take any S here. Since it has to return a string, I will just say unknown value. Now it will only do it in on the lookup collection, on this collection. It will not do it on the lookup 2. So for lookup 2 again I have to call its function. So since it returns an integer, I will just say 0 here. If nothing matches, it will just return 0. So in this case it will return 0. I mean these methods are individually defined for different collections.
So this get or else method is applicable for all the identifiers.
All the identifiers, I didn't get that question.
Like you defined a lookup, right? Val lookup. So
Correct.
then you calling the method get or else. It
Correct.
is a user defined method, right?
Yeah,
We are not defining it.
this get or else method is for only map collections. Any map
Ah,
collection you define, the map collection has this get or else. We can check that. Any map collection you define. So these are all the methods you can see. You can see that there is a get method available. Get or else method is available. We just use those get or else. Right.
Pramod, what happens if I just type without that lookup or lookup 2, if I just type get or else of S?
No, there is no such exist. I mean, as I said, a function cannot exist independently. It has to be
But
part of a class.
but few lines before you just mentioned get or else of S,
Right,
just
right.
like
Because I myself defined that function.
Okay, so the interpreter will distinguish that this is an inbuilt
Correct.
function and this is
Correct.
the defined function.
Right, right. It will know that this is my own defined function. I was just trying to showcase how it might be internally implemented. So the interpreter or the compiler knows that this is a function that is we have returned, because we are not associating this with any object. But in this case, if you see, we are associating with the lookup to object. We are calling this on this object. So that's how it differentiates. Unless I mean we explicitly specify that it is on this. You can have same methods in different classes. I can the idea here, what I'm trying to say here is the namespace. It's the namespace. I can have class ABC. Here also I can have get or else method. I can have class EFG also. I can have the get or else method. So I will say class a new object I'm creating of this class, new ABC. I can say ABC dot get or else. Similarly, I can say val EFG is an object of this class, EFG dot get or else. So I can use in this fashion. I mean, it is able to resolve that I'm calling ABC's method else. Here it is able to resolve that. I mean, we need to give the complete path. This class method I am calling get or else, because EFG is a object of that class, EFG class. So that's how it differentiates. I mean, we need to have a complete object and its method, complete things as a different. That will be unique. So I hope that was clear.
Yeah, Pramod. I mean, if we don't give the complete path, so will it resolve if the input parameters, set of parameters are different without the complete path as well?
If the parameters are different, yes, I mean to say, let's say it takes integer. I have one more get or else which takes a string. So I can call abc dot get or else. I can pass 10 abc dot get or else. I can say it will figure out that for this it has to, for integer it has to call this function, for string it has to call this function based on the data type. It will differentiate. That's what we call as function overriding, or sorry, method overriding. That's how it works. So I hope that was clear.
Thanks, Pramod.
So I think we will wind up the session here, and let's continue tomorrow. Tomorrow we'll see the object oriented part. So few things are remaining in Scala. Those things are nothing but the object oriented part. In that there is something, there exists a keyword called, Scala itself has a keyword called object. We'll see what is the uses of this object. Then we will say traits. Then we will see case class. Then we will see implicits. Probably it will take some more days to finish all this. These are the things that are pending: objects, traits, case class, and implicit.